Hello everyone, Dr. Chen here. So here, as promised, I'm going to record a example video on how to solve the shooting basketball problem. Now recall, basketball is moving in the air with only influence of gravity, so basketball is doing projectile motion. For projectile motion, velocity in x direction is constant. In the y direction, acceleration is negative 9.8 pointing down. Uh, so in the x direction, we use constant velocity motion to solve it. In the y direction, we need to use basically the same as free fall kinematic equations. Now let's look at this particular one basketball shot. A basketball player release a ball at a height which is 2.15 meter. The initial speed of the ball 11 meter per second. Launching angle is 50 degree. The basket hoop is 315 meter. So following this trajectory, the basketball, the height difference from starting position and end position is 1 meter. Okay, now let's check what the problem asks for us. What's the maximum height the ball reaches? And then what would be the height here, the ball at the highest position? And then second question, what would be the horizontal displacement of the ball? Okay, now let's solve the first one. Find the maximum height. Apparently we need to solve it from information in the y direction, right? So we find the initial velocity in y direction is, and we know that the initial velocity will always know acceleration in y direction for free fall, for projectile motion and free fall motion. And then highest point, we have discussed it several times by now. Which quantity does it give us? Here at the highest point, velocity should be 0 at the highest position. So we have 3 quantity, and we always said if we have 3 quantity, we can solve the unknown quantity. But this time it asks us height. So let's calculate this delta y. We want to find the equation that contains 3 variable and delta y. Check those 3 equations. Which one are you going to use to solve delta y? I would use this one. So V0y squared 2 times 9.8. Let's punch those numbers into the calculator. We find is 3.62. So this is 3.62. And we still need to take into consideration that this one is 2.15. So the maximum height is 3.62 plus 2.15. Okay. Question 1 solved. Now we go to the second question. What's the horizontal displacement? In the horizontal direction, the ball is doing constant velocity motion. Already know this, which is V0 sine theta. And plug in all the numbers, we can find the velocity 7.07. And we need to find this t. And this t cannot be solved from y direction. No, sorry, cannot be solved from horizontal direction. It can only be solved from vertical direction, the y direction. So what do we know in the y direction? We always know acceleration in one direction. And what else do we know? We know initial velocity in y direction. We already calculate. Okay. And okay, now let's look at the graph. See what's the other information we know in the y direction. Start from here, end up here. And the question gave us h is 1 meter, so which means the ball fly from here to here. The displacement in y direction is 1 meter, right? Displacement in y direction is 1 meter. And we can find, so 3 quantity in y direction, we can find out what is t. So which equation relate to 4 variables? We check, it will be the second one, that y equals v0y t 1/2 ayt squared. So it will give a quadratic equation. Now we need to solve this quadratic equation. I have posted instruction on how to build a program to solve a quadratic equation on your TI-83 or TI-84 calculator. So you can check it out, and we can find out the two solutions of this quadratic equation. Or then which one is the correct time for us? If we look at the diagram, so there are actually two instances. The displacement of the basketball is 1 meter. One is here in the loop. And now we can compare. So this time, the corresponding to the ball get to this position. And this time, corresponding to the ball get to the hoop. So we will discuss, discard this solution. We will keep 1.5 line as our solution. What's the time it takes for the basketball to get to the hoop? So now we can calculate what's L, initial velocity in x direction, times the time will give us 11.24 meters. So L is 11.24 meters. Thank you very much for your attention.